Welcome students to lesson 10 of the natural hazards topic. In this lesson, I'm going to help you use the knowledge that you gained from the previous lesson about density and air pressure to understand the patterns of weather around the world. In particular, I want you to know why there are areas of the world that have regular rainfall and areas of the world that rarely receive rainfall. This will help us to explain the distribution of storms and deserts and rainforests around the world. Please write the date, title and learning objective and have a pen and paper ready to learn. Time to review prior learning. Write 1 to 10, answer the questions from memory and then mark your answers. Game time. 1. The layer of air around the Earth is the atmosphere. 2. Air pressure means the amount of air molecules in an area. 3. Air pressure is usually lower at higher altitudes. Remember, this is because the Earth's gravity is weaker the further away from the Earth you go, meaning that the Earth can hold on to fewer molecules of air. So there's less air in a given area, lower air pressure. 4. Evaporation means when water warms up and turns to gas. Or when any liquid warms up, I should say. 5. High air pressure on the ground means air is sinking, because the air is falling towards the ground, it's building up. 6. Low air pressure on the ground means air is rising. 7. When air rises, it cools down. 8. Geothermal energy in Iceland. 9. The Indian Air Force sent 13 helicopters. 10. The Australian NGO called the Red Cross. Give yourselves a mark out of 10. If you got 8 or more, excellent work. You've really understood these ideas. Any questions that you got wrong, test yourselves on them repeatedly until you've memorized them. Okay, in this lesson, I'm going to help you use the ideas of density and air pressure that we learned last lesson to understand how air moves around the world, and this will help you to understand why there are rainforests and deserts in different parts of the world. Let's go. First of all, we need to understand this question. Why are there differences in temperature around the world? And this is all to do with the fact that the Earth has an atmosphere and the Earth is a sphere. These red lines show sunlight. When the sunlight from the sun travels through space and hits the Earth at the equator, so 0 degrees latitude, if you remember, are the horizontal invisible lines that go around the world that show the distance of places from the equator. When the sunlight hits the Earth at the equator, it is focused over a very small area. So all that sun energy is focused over a small area, meaning that area gets very hot. Additionally, because the sunlight is traveling directly through the atmosphere like this, it has the shortest distance of atmosphere to go through. And so the smallest amount of air is absorbed by the air in the atmosphere or reflected back into space, and so the largest percent of sunlight reaches the ground at the equator, and consequently the equator is very hot. Use this example to help you understand this. If you take a magnifying glass on a sunny day and point it directly at the ground and focus the sunlight over a small area like this, you can create fire on a piece of paper, because all that energy from the sun is being focused over a very small area. That's exactly what happens at the equator. That sunlight is focused over a small area because it's pointed directly at the Earth. There's no angle like this, it's straight on. And so it gets very hot in areas near the equator. But what happens when you angle this magnifying glass further away from the paper so that the sunlight is spread out? Well, now that same sunlight, the same amount of sunlight, is spread over a much larger area. And so the amount of energy hitting any part of the ground is much lower, and so the ground is much colder here. That's why in the North Pole and the South Pole you have lots of ice. It's very cold there. Similarly, if you angle a magnifying glass on a piece of paper on a sunny day so that the sunlight is spread out over a large area, the paper will not burn, or it won't even warm up really. The same amount of energy is spread over a larger area. Not only that, but now that sunlight, if you look carefully at this line here compared to these lines here, that sunlight is having to travel through much more air in the atmosphere, meaning that much more of the sunlight is absorbed by air in the atmosphere, so it doesn't reach the Earth, and much more is reflected, bounced off the air in the atmosphere back into space. So again, a much lower percentage of sunlight reaches the Earth at higher latitudes. The highest possible latitude is 90 degrees latitude north and south of the equator. The lowest latitude is 0 degrees at the equator. So the higher latitude you go, the colder it gets because of the angle of the sun hitting the Earth. At the equator, sunlight hits Earth directly. At high latitudes, sunlight hits Earth at an angle, and so it's much colder here. That is why there are differences in temperature around the world. It has nothing to do with the Earth's distance from the sun. This is important. The reason air moves around the world is because there are differences in temperature around the world. Hold on to that idea. Temperature and differences in temperature affect air pressure at the ground. Let me show you how. At a place where there is high pressure, here's what happens. High in the atmosphere here, the air is very cold. And when it's cold, it becomes denser. The atoms of air come together, they condense, and so it sinks. The air, cold air, is sinking towards the ground here. And so the air builds up near the ground. You get air like this, molecules of air close together. You have high air pressure. Well, why does this affect the weather? Well, when you have high air pressure, the air is sinking, and so it's warming up. And when air warms up, it cannot condense to form clouds. Clouds form when water vapor, which is water as a gas, rises and cools down at higher altitudes, because it's colder at higher altitudes, to form clouds and therefore rain. When you have high air pressure, the air is sinking, and so that water vapor cannot rise, and so you have no clouds. And so when you have a day with high air pressure, you have sunny weather. Near the equator, this sunny weather leads to very hot days because the sunlight can reach the Earth's surface. It's not blocked by clouds. At very high latitudes, for example near the North or South Pole, sunlight like this means very cold days because all the heat from Earth can escape to space and it's not trapped by clouds, like a duvet on a bed. So when you have high air pressure, you have sunny weather and clear skies. What about low pressure? When you have low air pressure, here's what happens. First of all, why do we get low pressure? We get low air pressure because the air near the ground has been heated up by the sun. And as it's been heated up by the sun, its atoms have spread out, it's become less dense, and so it's risen upwards here. As the warm air and water vapor, which has evaporated from the sea and the lakes and the rivers, have risen up, they have cooled down higher in the atmosphere and condensed to form clouds. The water vapor condenses into water droplets, liquid water droplets, which we see in the sky as clouds. As these water droplets join together, they become too heavy, and so they fall as rain. Now, why does this lead to low pressure at the ground? Well, when the air has risen, there is now less air remaining near the ground. It looks like this. You have fewer molecules of air, lower air pressure. And consequently, when you have low air pressure in an area, you have rainfall. And when you have high air pressure in an area, you have clear skies. So this, in a very simple cartoon, explains why high and low air pressure lead to clear skies and rainfall. Now let's show you how this works on the whole world. This complex looking picture shows how air moves around the world. The arrows on this picture are air moving. Blue arrows mean cold air, red arrows mean warm air. These lines going around the world, the white lines, are the lines of latitude. 0 degrees latitude, the equator. 30 degrees, 60 degrees, and then at the North Pole, 90 degrees latitude. 30 degrees south, 60 degrees south, 90 degrees south, the South Pole. So, let's explain what's going on here. At the equator, 0 degrees latitude, and at 60 degrees north and 60 degrees south, air is rising. Why is this happening? At the equator, the intense heat from the sun is warming up the air and the water, causing the water to evaporate and warm up, and causing the air to warm up. This makes both the water less dense, as water vapor is warm and less dense than the surrounding air, and the warm air to become less dense than the surrounding air, and so they rise. This means that in these red areas, these red circles, you have low air pressure, and consequently, in the UK, at 60 degrees north, or just below 60 degrees north, in this area here, you have regular rainfall, because the UK regularly experiences low air pressure. These circles of air are called convection cells. What is a convection cell? It is simply the movement of air in a circle from warm air rising to cold air sinking. And they do not really move around the world. Their position on the latitudes of Earth do not move around the world. They don't go further north or further south. They stay where they are. And at the equator, because the air is rising so fast and it's being heated so intensely, and so much water vapor is rising all the time, you get rainforest because clouds are always forming here, and so it's always raining. And so you have rainforests along the equator, such as the Amazon rainforest and the Congo rainforest here. But what about these areas where the air is sinking? Here. At 30 degrees north and south, and 90 degrees north and south, cold air from high in the atmosphere is denser and is sinking regularly throughout the year. This means that at these latitudes you have usually got bands, these are called bands, of high air pressure. Cold air is sinking, so no air can rise, so you can't have clouds condensing, so you can't have rainfall. And consequently, at these latitudes, you have hot deserts at 30 degrees north and south because there's no rainfall, and intense heat from the almost direct sunlight. And at 90 degrees north and south, you have the very, very cold polar areas. This is Antarctica. There's very little snowfall or rainfall here, and it's so cold because of the extreme angle of the sun, meaning that the sunlight is spread over a very large area. And since the air is sinking because it's very cold, you have very little rainfall. So let's review. Air rises at the equator because of the intense heat of the sun hitting this area of the Earth directly. As it rises, it cools and condenses to form clouds and therefore rain. As it reaches the very top of the troposphere, which is the upper limit that weather in the Earth reaches, it spreads out as cold air, spreading out to 30 degrees north and south of the equator. As it cools down, it becomes more dense, and so the air sinks at 30 degrees north and south of the equator, creating two areas of high air pressure, leading to hot deserts without rainfall and clouds. As the air reaches the ground, it warms up again because nearer the ground, the atmosphere is warmer. And so it spreads out towards the equator and towards 60 degrees north and 60 degrees south. And that warmer air eventually becomes such a low density that it rises again. And so at 60 degrees north and south, you get rising air, low air pressure. And so you get weather like this in the UK. These convection cells, called the Hadley cell, between 0 degrees and 30 degrees, simply are the circulating movements of air between these latitudes due to the rising warm air and cooling and sinking cold air. This whole picture shows how air moves around the world because the Earth is heated unevenly by the sun. This movement of air would not happen if the Earth was not heated most here and least here, because air moves for the simple reason that it's hotter in some parts, leading it to rise because it's less dense, and colder in other places, leading it to sink because it's more dense. If air was all the same temperature, it wouldn't rise or sink. We call this picture of air moving around the world like this global atmospheric circulation. And you need to understand this movement of air around the world and be able to explain why two things happen. Number one, why there is low pressure along the equator and high pressure at 30 degrees north and south. And number two, why you have rainforests and wet areas at certain latitudes, and why you have deserts and polar cold areas at other latitudes. If you can explain those two ideas, you've really nailed this topic. Answer these questions using your understanding from memory. So number one, at the equator air is usually rising. At the equator there is usually low air pressure at the surface. 3. At the equator there is often rainy weather. 4. You find deserts at 30 degrees north and south. Remember, these are not temperatures, these are lines of latitude, horizontal invisible lines that show the distance from the equator. 5. High air pressure when air sinks. 6. You need both, low air pressure, rising air. 7. When air rises, it cools down. 8. When air cools, it condenses. Give yourselves a mark out of 9, because number 6 is worth 2. If you got 8 or more, fantastic, you've really understood this. If not, watch the explanations again, and be careful to really listen to that last explanation about global atmospheric circulation. Time to embed learning. Read the questions, write them, answer them using your understanding, and then mark your answers. Number 1. You need that exact definition. 2. Make sure you use these keywords. All 3 points needed for 3 marks. 3. Again, both keywords needed. And 4. All 4 points needed to explain why there is regular rainfall along the equator, and keywords needed. Give yourselves a mark out of the total and add any corrections or missing points in green pen. If you lost only 2 marks or fewer, you really understood this. If you lost more marks, in a week's time come back to this, watch the explanation again and attempt these questions from memory. I had a video that was going to illustrate how warm air rises and cold air sinks, but I will link that in the description below this video. From this lesson, write 2 questions and answer them from memory. In a week's time, test yourself on those questions to see if you remember the ideas. In the following lessons, I'm going to introduce tropical storms and give you a case study of a particularly devastating example. Join me then.